So for this one here, we're given the graph f of x equals x to the power of 3. First thing we're asked is the domain, range, and end behavior. So domain, it looks like the x values are going all the way to negative infinity and positive infinity. So my inequality is going to look a little bit like this. My set notation is going to include the same inequality here. And my interval is just my two endpoints, which in this case are infinity and negative infinity, and it never touches those, so we use parentheses. Now for the range, I'm going to look at this and see that it goes down to infinity, to negative infinity, and up to positive infinity. So these are pretty much going to look identical to the previous one, except we're using the range, so it's the y values. So all of these are going to look identical, but with y for the variable instead of x. For the end behavior, so for end behavior, we're always looking as x approaches infinity, it looks like y is approaching infinity as well. Because as we're going to the right, the y value is going up. As x approaches negative infinity, so as we're going to the left, looks like y is approaching negative infinity because it's going down. So how is the range of this function? I'm going to go ahead and erase this really quick. How is the range of this function affected if we change the domain and restrict it to -4 to +4? So first of all, when we're restricting domain, remember it's just like we're looking through like a spyglass and only seeing between these two lines here. So what that means is that it changes the range because now the range does not go on to infinity. The range goes up to what looks like, I don't know, about, let's call it about 63 or 64 here, and then it goes to about -63 or -64. So our range changes instead of from negative infinity to positive infinity, it's going to -64, including that number, to +64. So it changes the range a little bit here. Now graphing that, again, it's basically just graphing this exact same thing except cutting off those edges here. So I'm going to go ahead and kind of sketch this out to be right about here and right about there.